My name is Pat McDowell. I'm a security solutions architect at AWS. And joining me today, I'm lucky to have Kevin Stoltz of Symantec here. He's the Director of Product Management, and Tom Castellano, a Cybersecurity Engineering Lead at LifeLock. Today, we're going to talk about how LifeLock migrated to AWS and how Symantec Cloud Workload Protection helped them in their journey. Okay, so let's talk about what is driving AWS adoption. I'm not sure if anyone here is new to AWS or veterans, but there's some key trends we're seeing why adoption to AWS is growing extremely fast. First of all, increased agility. You can really empower your developers to just move faster than they typically can. Flexibility in terms of, hey, there's no upfront costs. If I just want to experiment for a little bit, that is that's quite awesome and powerful. As an example, we now offer virtual instances with 4 terabytes of memory. If you ever want to experiment with that in the on-premises world, that was not possible. I'm not sure if anyone has tried asking their IT department for 4 terabytes of memory just to play around for a few hours that you didn't need anymore. That wasn't really possible in pre-AWS days. You're also able to go global in minutes, as in, hey, instead of just deploying to a single data center, let's deploy to 14 regions around the globe all at the same time. And also lower cost and transparency. I talked about the flexibility, but we now bill EC2 at per second intervals, which is quite amazing. What are some compelling reasons that customers are moving to the cloud? First and foremost, people start experimenting with dev and test. But right after that, you start moving to production apps because maybe there's an app refresh coming up and they want new materials. They want to not be in their data center. So they start moving their production apps, their back office apps, their greenfield apps. Then we start seeing new applications. No longer people ordering hardware to put in their data centers. Like, I have a net new need for a new application. Let me build that in the cloud first. Then we have kind of a upswing here if you look at point number 4, and you start seeing a mass migration. As time goes on, our customers want to journey deeper into the cloud and more move things there. And finally, you can transform your business. What I mean by that, you're actually rethinking how applications work. Maybe you're an expert, you want to harness machine learning and AI to better improve your business, and help harness that power. So the cloud is able to address all of these needs. But one of the reasons why the cloud is so amazing is because of security. Why is security so important? Well, it's really hard to go a week without hearing a major cybersecurity incident that affects all of us. As you can see here, the cost of a data breach is only going up, with about $6.5 million as the average rate it costs per incident. But as you can see, about 70% of customers would try to avoid businesses who experience a security breach. So this is no longer InfoSec's problem, but is actually a chief executive problem or a board problem as well. So now everyone needs to be on page with cybersecurity because it affects the entire company. One of the reasons that I talked about the major reasons why customers were moving to AWS before. And security is actually a reason we are seeing large move to the cloud in general. It used to be that people were concerned about the security of cloud, but we're really seeing security as a reason why largest enterprises are moving to the cloud. And by running your workloads in AWS, you inherit security controls that you never were able to have on premises. For example, you can gain insight across your entire environment via just a single API call. We are seeing a significant trend of businesses choosing AWS for those security reasons. In fact, Rob Alexander, who is the CIO of Capital One, stated publicly that he believes AWS enables Capital One to operate more securely in the public cloud than they were ever able to operate in their own data centers. At AWS, security will always be our top priority. We're going to do everything we possibly can for you, but we can't do it all. And that's why this slide is so important. This is the shared responsibility model. And in order to secure customer workloads, we have to embrace this shared responsibility model. Essentially, what it means is AWS manages and controls the components from the host operating system and virtualization layer down to the physical security of the facilities in which the services operate. And you, our AWS customers, are responsible for building secure applications. So we help and provide a wide variety of best practice documents, encryption tools, and other guidance. that customers can leverage for delivering cloud applications. In addition, AWS partners like Symantec offer products and solutions and features to help customers meet their security objectives. So the shared responsibility model follows the premise that you cannot deploy secure applications by yourself because you have to rely on AWS. And we cannot secure things for you because we do not have access into your EC2 compute instances. So it really takes AWS, our partners like Symantec, and our customers working together to create a truly secure environment. Now, as a customer, you have the responsibility to choose such things as where you actually store your data, what type of encryption do you use, and who should have access to it. So that means you are responsible for such things as patching operating systems EC2 and defining your desired network topology. We refer to our side the shared responsibility of security of the cloud. That's the bottom portion right there in yellow, and you, the customer, are responsible for security in the cloud. But one of the great things about cloud is that AWS customers inherit all the best practices of AWS policies, architecture, and operational processes built to satisfy the requirements of our most security-sensitive customers. So at AWS, we actually manage over 1,800 plus security controls, so you do not have to. However, the important thing to remember is that you always maintain full ownership and control of your data. So at AWS, we have a world-class team of security experts monitoring our systems 24/7 to protect customer content. And we also provide native security services and deeper visibility into what's happening in your environment. As an example, our logging service, AWS CloudTrail, provides visibility into all AWS API activity that has occurred in your environment. Essentially, every action that is done in AWS, there's an audit trail for it. And this includes something as large as deleting a data volume to simply disconnecting a network interface. Other security services we have include Amazon Macie, which uses AI plus ML to detect access patterns to data stored in S3. And it also classifies that data for risk and content such as PII. So we'll actually tell you if anomaly activity occurs from one user accessing data in S3 that doesn't typically do that, it can send an alert. We also have Amazon Inspector, which helps assess applications for vulnerabilities before you get them into production. So another reason why our business has grown so fast is availability and reliability. AWS builds its data centers in multiple geographic regions, as well as across multiple availability zones within each region to offer maximum resiliency against system outages. So what that means is a region is a cluster of availability zones, which is a cluster of data centers. So when you put your application in one availability zone, you're actually building across multiple physical data centers. And when you're building across multiple availability zones, which is the best practice, you're actually in at least 4 data centers at the same time. The AWS global infrastructure is comprised of 44 availability zones across 16 geographic regions worldwide. And we just announced plans for 17 more availability zones in 6 more regions in Bahrain, China, France, Hong Kong, Sweden, and a second AWS region in the United States for GovCloud. And we always design our data centers with significant excess bandwidth connections so that if there's a major disruption occurs, there is sufficient capacity to enable traffic to be load balanced to remaining sites, minimizing customer impact. In addition, we have, everyone moves in the journey to the cloud, as we talked before, but a lot of customers still want to use things they have on premises, like Active Directory, and that's still possible. So we provide tools for enterprise customers to integrate with Active Directory, such as Direct Connect and IAM in our directory services. Direct Connect is a private connection between your data center or your colo and AWS directly. And then you can use Active Directory to put your users into AWS IAM. We also offer tools like AWS Key Management Service, KMS, or Cloud HSM, which can help manage the full lifecycle and access to your cryptographic keys. AWS KMS is a fully managed service that makes it easy for you to create and control the encryption keys used to encrypt your data. So you can use those keys for EBS volumes and S3 objects as an example. So last but not least is our security assurance NASCAR slide, essentially. And AWS has achieved a number of internationally recognized certificates and accreditations where we demonstrate compliance with third-party assurance frameworks such as ISO 27001, PCI, SOC 1, 2, and 3, HIPAA, and FedRAMP for federal government systems, as well as the DoD. And we are constantly listening to customers who want a different set of certifications, and we're always iterating there. And all these reports are available to you via the AWS Artifact service right in the AWS console. The important thing to understand is just because, for an example, if you're running a PCI application at AWS, that does not make you PCI compliant. That is a joint effort of the shared responsibility model. So AWS, yourself, and partners like Symantec. And at AWS, we have customers in all industry segments, including ones that are, a bit slow to adopt newer technologies, such as oil and gas, financial services, and healthcare. Now with that, I'm going to move it over to Kevin Stoltz, Director of Product Management at Symantec, so he can tell you a bit about cloud workload protection.
Thanks. So again, I'm Kevin Stoltz, Director of Product Management with Symantec, and I'm here today to talk to you about cloud workload protection. And what I want to start, just as you were just hearing from Patrick, right? We see a big shift to using Amazon as the cloud, and exactly what it's hitting on. It's about agility, the ability to have lower cost. And we're even running into ones who are very concerned about regulatory and seeing the progress in Amazon, as you just saw on the slide, as well as just running into problems where they have to go there. They can't build data centers fast enough where they need them to support their business. As they do this, this increases the heterogeneity of their environment. So now they have more platforms that they need support. We see a lot of adoption of Amazon Linux. And you see them moving into cloud native workloads where they're then moving to containers. And so the data center has evolved to the point where I have a very heterogeneous environment with many different operating systems, from old legacy NT systems, which we still see in some of the large financials out there in the world that maintain and just keep going, to the next generation Docker containers and cloud native, which writing directly to S3. Completely different problems that they're trying to solve, and they need to be able to provide security as they do that evolution, both for the great new workloads that they're doing in Amazon, as well as protecting their classic traditional workloads. So at Symantec, with cloud workload protection, we're focused on providing a single solution from a single console to protect all your workloads. And one of the first things we're looking at, as you heard Patrick talk about, one of the really awesome things we can do with Amazon is we can give the visibility of public cloud and deal with that very elastic, agile world. So as we look at this, one of the first things that we can do for you as you look at I am on Amazon is, how can I give you something that you've never been able to do in the on-prem world, of being able to know, what do I have, where is it, and are they secure? So here I can know exactly where my workloads are, exactly what kind of workload it is, and whether or not it is secured. So with cloud workload protection, what we're doing is we're giving you continuous visibility into your Amazon as well as your private cloud to let you know where your workloads are, the metadata from Amazon, as well as then augmenting that with our software discovery service. We've had this in our data center security products for a while. What this enables us the capability to do is not only tell you where are the workloads, how many of them you have they been secured because they're cloud native and DevOps or the image automatically secured them, but we can also say, hey, here are these additional workloads that somebody has spun up. Tell me what is running on those workloads. And of those things running on those workloads, are they secure? Do they have vulnerabilities in them? I think one of the most interesting stories I had from a customer was one who had recently adopted Amazon. and he had given approval to roll out 100 new servers to Amazon for a new business process. He went back 2 months later, connected with our tool, and said, why are there 1,000 workloads? He dug into it and found he had quite the bunny farm. He said, my bunny farm was great. They took and deployed, and their service was more successful than they expected, so they quickly expanded regions, and I could see the regions they expanded in. But then I also was able to see that I had a number of people who took Amazon up on, I want to test that petabyte server, and then forgot to secure it, forgot to shut it down. And so one of the big values of CWP, before you even get to placing an agent on that workload in order to secure it, is identifying the workloads, identifying are they public or private, where they are, as well as the full topology of your network to easily identify outliers and identify things that are approved and allowed in your environment versus those which are high risk and need to be shut down in the environment. As Patrice was covered, it's very much a shared security model. Amazon helps us give you that visibility of your workloads, exactly where they are at any point in time, to be able to instantly tell you what your posture is. Our focus is then on taking and being able to provide the right security controls to then protect your data, ensure the uptime of your workload, ensure when you see the alert, many of you have seen this week, about Adobe and the vulnerability which was released. How do I know? Am I secure? So with cloud workload protection, we've had a focus on how do I protect your workloads. And what we see as the data center evolved is two different types of workloads with different needs. And our goal is to apply homogeneous control across a very heterogeneous world. So regardless of whether your workload sits in a bare metal on-prem running AIX Solaris, or whether you have something sitting on your VMware OpenStack or sitting in Amazon, I can apply a control and have it apply across those workloads. And what we see is in today's world, you're seeing traditional workloads. These can reside on-prem. They also, we see them moving in the cloud. And these are general purpose computing. They're IT managed. Somebody spins up some particular app they bought from a vendor, and it just runs. And what we hear from them, they've got a standard IT ops, standard patching, but they tend to have a 400-to-1 or so ratio of servers to admin, and those servers move around. They're not sure what's on them. They're general purpose compute. And the controls they're looking for are controls that they can apply without knowing anything about the workload. And so what they start with is they start with a reactive approach, right? Anti-malware, so I'm going to ensure that malware cannot impact that box. Real-time file integrity to meet my PCI compliance, ensure I'm doing my integrity as well as detecting anomalies and breaches within my environment. And then the more maturers then move to that next level where they start moving into a proactive app control on the server. And so we have solutions in that today with CWP and can provide those controls, whether that traditional workload sits on-prem or whether it is being hosted within the cloud. We've seen many customers just taking and needing those traditional workloads due to scale or cost and shifting them to the cloud. The other type of workload is the cloud workload, often referred to as cloud native. And this is where there's a massive explosion in Amazon of instances, as well as now you're seeing containers with the Docker container service and the Lambda functions. And what you see in this world is a very different need. These workloads have a gold image. They are developer DevOps managed, and many of them have a short lifespan. So what we see with these workloads is an image is built for a specific microservice or application what is being run, and then it is spun up within the cloud as it is needed as the business needs. So in a busy period, you'll spin a bunch of them up, and then in a slow period, you'll spin them down. And then every so often, month or quarter, you will see them roll over to new images. And during that time span, DevOps wants to maintain that gold image. They want to have a consistent, this is the server, I spin it up, it's secured as soon as it comes up. I don't want any lag from spin up to it getting updated with the latest protections. So they're taking a proactive approach rather than reactive. And some of that is because they have the capabilities. There's always been a desire with traditional workloads, but knowing what you had, taking a proactive hardening approach with app control a harder solution in traditional. But in cloud native, they know exactly what is running and is a consistent thing. So what this enables us to do is to be able to have a policy which Symantec provides out of the box that provides the OS hardening. And one of the really great things our customers see with that is the fact that I can have an OS hardening policy around any specific control, around who's allowed to use SU and sudo and what they can do on the Linux workloads. But they don't need to know and understand how it's implemented on an Ubuntu versus an Amazon Linux versus an HP UX, right? Symantec handles all that behind the scenes in cloud workload protection. And with these cloud native workloads, app control becomes very easy, right? Symantec's app control provides a no knowledge required approach, where as I run my cloud native workload through its CI/CD pipeline, I'm able to see what is running, allow those things to run, and only those things to run. And then as they move to full patch mitigation and placing castles around their applications to protect their data, we can do full app isolation. We can, in learning mode, watch the activities of that application and ensure that no application can touch its data, and ensure if that application has a vulnerability, it cannot be exploited. So the benefits on the cloud workload side is that fact that I can have an image, I can even embed the security policy within my image, no communication back to CWP, and have instant on security with no change to make it so DevOps can roll out secure workloads as they need at any point with no delay for updates and ensuring that I have robust security controls. Those robust security controls ensure I can block advanced threats and zero-day threats, like as we've seen it with WannaCry and Petya and Shellshock and Dirty Cow. Our proactive approach ensures that only the services that are on the box are allowed to run. New services cannot be started or added or used to manipulate the operating system, stopping the zero-day attacks, prevented the unauthorized changes to the workload. And the other really powerful thing in a cloud-native environment with our learning mode is the ability to do anomaly detection and easily identify suspicious behaviors. In the past, we saw real-time file integrity's primary purpose was to check the box for a compliance auditor. Now, because I can, in a CI/CD pipeline, see the activity as that workload is exercised before it goes to production, I'm able to learn and say these are allowed activities to the point where then I'm in production, I know I have a suspicious activity. I have one of our customers has taken this to the point within their container environment to where if they see an activity, they are automatically doing what they call in their environment a repave, where they take and bring down the production containers one at a time, bringing up new ones, ensuring nothing in the environment is out of sync from that initial gold image of the way they want to run their application. And then also then is providing that ability to ensure I have protection for malware, whether it's attacking the operating system or the applications. And what you're seeing on this screen is a really exciting feature we built into this to help customers prioritize. One of the things we see is I've also got those traditional workloads out there where I haven't been able to completely harden them. I've got generic antivirus applied, which provides that reactive. And I'm still dealing with how do I know whether I'm protected, right? And what is the latest CVE of the day and where am I impacted? So what you're seeing here is as we have these controls, we have the ability to identify where is it most critical to ensure you get the controls applied and answer the question of the day, because our discovery service has discovered whether or not it is running a unpatched application, operating system component, can identify which ones are vulnerable as well as the threats. And what you would have seen in 2 days ago as a matter of fact, is a new CVE come up as the Adobe Flash problem came to light and identify exactly where that is and the fact that there is a in the wild threat so you can quickly remediate and identify and remediate the risk. So one of the other things we really focused on as we built cloud workload protection, we've got visibility, we've got the controls, we've got APIs and the ability to build the policy into the image. so where it's secured from the start for DevOps. But what we saw is in the world of cloud and the highly agile space is you need to have a very DevOps-focused approach, but you need to think of it from a standpoint of knowing that besides the DevOps spun up infrastructure as code, you're going to have people going to the marketplace to try out the petabyte and finding it met their need and needing to leave that up and running. So we needed to build a system where as the customers were working in cloud, I can identify the workload, identify whether or not the security controls have been applied, and make it very easy for the operator to be able to identify what are the workloads that are not secured, where they tried out the petabyte system and loved it and now need to keep it. What's on it? How do I secure it? So with CWP, we're taking, and as I was covering earlier, we reach in and identify from the metadata the topology, so I can easily, as somebody looking at it, identify what's there, identify whether the workload's already secured, whether the agent's present, whether it's a public or private. I can do all of that without having an agent on it, as Amazon's rich APIs enable us to provide that deep visibility and help the security operator know what is the risk. The next piece I can do is I have the ability to then take and look at what's running on that workload, and we use a rules engine to match that against the policies that the corporation has in place in Symantec's out-of-the-box hardening and monitoring policies, such that I can recommend to that administrator, I see what has come up is a new box. This is a database server with massive memory. I need the ability to then apply a policy. It will then have recommended a policy. It will also look at the tag, such as a PCI tag, and using that tag, ensure it's recommending to that administrator which policy to apply so that they can quickly and easily do their job without having to go be a detective and determine what is the server, what is running on it, what do I need to apply to it. And of course, if we focused on building with Amazon and being a partner, we have flexible pay-as-you-go licensing model tied into Amazon Marketplace, as well as the ability to do annual subscriptions for those who's looking to continue doing this as a CapEx, and the ability to tie the two together, where I can buy for the things I know I have in the cloud, yet have the ability to, and agility to easily expand and be billed only for what I use wherever I am using it. Finally, there's a very special workload, which is a container. And the reason I always bring this out separate when I think about controls is where containers are different is in the old world, and you thought about hybrid, a server was a server was a server. It can be sitting a Windows box on bare metal versus on VMware versus on OpenStack versus on Amazon. I can take my security program, processes, and controls and continue the same thing as I've been doing, right? I apply my security controls like Symantec security agents to protect that workload regardless of where it sits. When I move to a container has taken the virtualization to the point where I virtualize just the app, not the operating system. So gone is the ability to have a security agent within that container providing that protection. So here, what we've looked at as we built this and focused on building hybrid, ensuring we can protect the cloud-native workloads, is we took a low case of, okay, so as you move to containers, we need to figure out how do we solve that problem? How do I secure it without being inside the container? The second is, what are the threats to the containers? And what we found is there's a very high rate of change in the container environment, even higher than you see within a workload in Amazon, where they are continually updating these microservices. You don't see all microservices for an app changing every day, but certainly many of these applications consist of sometimes 50 to 100 different microservices. And the teams building those microservices, at least on a monthly cadence, are updating them. So as you see a constant change in the environment of some new piece of code being released into the environment as an image. And what we've been seeing in the real world attacks and when the pen testers, and there's a reference here in this slide of what I think is an excellent detailed write-up of exactly how the attackers are going after the containers, which is because of that high rate of change in the code that's running, is finding vulnerabilities in that code, and then they're attempting to use that to get to the supporting infrastructure and framework and kernel underneath, such that they can gain a foothold within the environment. And by and large, as you will see if you check out the RSA video or the pen testers' other deep dive, they've reached a number of tools, I think really at the forefront of this, is they're attacking that next layer down, the supporting infrastructure, regardless of what you've chosen, whether you're using a Kubernetes or any other piece. That there are many different flavors here to manage the containers, to spin up a privileged container, which looks like the others. And so our whole goal as we looked at being able to secure containers is how can I, again, provide that homogeneous control such that I can do my PCI real-time file integrity monitoring, whether or not it's a container or workload, wherever that workload sits, as well as being able to provide the right security controls to protect your containers. So with containers, we have the ability to, again, provide that visibility, just like with Amazon, where I can give you visibility of your instances where you sit. Here I can give you the visibility of what containers you have spun up in your environment, what those are, the Docker command that was actually used to launch that service, and then full security monitoring of that container. So if I have security monitoring, which says the Apache config files aren't allowed to be changed once they're deployed, I can see any changes, identify the exact change, whether that a change occurred within an Apache container, Apache running on the instance within Amazon, or Apache running bare metal on a AIX box in my on-premise. So full monitoring of the activity. And then frictionless security. Here we have our agent on the host and nothing within the containers. And below that, I'm able to provide full containment of the container in isolation, such that I can apply controls to control process, resources like file, network, and what the container is allowed to do. And what we have found is one of the really great things about containers, it's all about escaping out of the container and getting to the infrastructure and the OS. So by applying just the default out-of-the-box policy, I'm able to ensure my containers cannot escape and get to the operating system or the underlying framework, regardless of whether there's a vulnerability in the container or a vulnerability in the OS itself, like we saw with the dirty cow kernel vulnerability, which not only impacted services but containers. I can ensure that that container cannot escape. And one of the nice things we've done for you in the CWP trial environment is giving you the ability to take and play with dirty cow and be able to see exactly how the controls are able to ensure that container is contained, and when the access to proc mem is attempted, the monitoring and alerting of that attempt to attack. And of course, DevOps, right? REST APIs to have full control over what security controls I'm applying on my containers, which is critical in a container world, as they are not managed by a person sitting at a keyboard clicking on the mouse to say go place security controls, but they are DevOps spinning up the workloads and applying the security as the containers are deployed. And finally, containers added a new challenge, which has really brought us to focus on the Amazon S3 storage. As you heard earlier, Patrick and the team at Amazon have been looking at Macy and how do I keep an eye on making sure that sensitive data is getting classified on the S3. What we've been hearing from our customers as they are using instances or containers or Lambda to accept inbound information from other businesses and consumers, how do I ensure that the data I'm receiving is not malicious? We've already seen incidents at 2 customers where their front end is accepting inbound. It's supposed to be, one was a claim form. It's supposed to be a PDF. Another was supposed to be accepting resumes for somebody wanting to apply for a job at the company. And the key was that came in, it hit a container service, which was writing off to S3. It's Linux. It didn't bother it. But when it moved through other containers in one case, and then to the endpoint, they were seeing that they were a transport mechanism for malware. In one case, the secondary processing service, the microservice that picked up that file to process it, when it hit the malware, it was crashing the service. So there is a denial of service that an attacker could apply to their environment. So what we're doing with CWP for storage, which is available headless beta now and is scheduled to be out this winter, shooting for a November timeframe, is the ability to have real-time anti-malware for S3. So as the instance container Lambda is attempting to write to S3, we're giving a verdict and ensuring that it is not containing malware. And the other piece we're already seeing used in that with the headless is the ability to take my application and have my application ask for a verdict at any point during processing to ensure that the data is clean and is integrated with my application. So as a whole, what you've seen today is information about cloud workload protection for protecting all of your workloads from a single console, the ability to deeply integrate with Amazon in order to provide you the visibility and controls necessary to secure your elastic cloud-native workloads, as well as traditional workloads which are running in the cloud. What I'd like to do at this point is turn it over to Tom Castellano of LifeLock to talk to you a little bit about LifeLock and how they used CWP within their environment.
Great. Thank you very much, Kevin and Patrick. As Kevin mentioned, my name's Tom Castellano. I'm a security engineer, one of the lead security engineers at LifeLock. One of my responsibilities is to ensure cloud and container security, workload security. So what I'll do for the remainder of the webinar is to kind of go over our approach and how we evaluated cloud workload protection in an effort to help any of the attendees. If you're close to using Amazon or CWP, or maybe if you're already deep into AWS, this will give you a good, hopefully, baseline and approach to evaluating CWP in a real-world production environment. So we currently deployed CWP in our AWS environment, and I just want to give a quick background and for context purposes, kind of give you an idea of what LifeLock is. If you're not familiar with LifeLock, we're a US-based company. We're identity and theft protection, and we have 5 million members and growing. We provide identity protection. We also do restoration services for our members that, unfortunately, if they're subjected to identity theft. So, as Patrick mentioned, and Kevin, security was our top of mind priority when we migrated to AWS. So, not only protecting our workloads, our data, our infrastructure, we leverage CWP as one of those best-of-breed technologies to secure our on-premises and cloud workloads. And I just want to give a quick background. It wasn't kind of like ultimately, like the migration wasn't like overnight. It was many months of planning, execution. It just wasn't a switchover. So it was paramount to ensure security and compliance during the entire migration. It was one of our top of mind priorities. Amazon provided that natively, but also Symantec provided that extra layer of protection and control that we needed for PCI readiness. PCI readiness to ensure our compliance and controls were in place as we migrated to AWS. So we migrated not only just our security stack, but our full data center is in the process of moving. It has been in the process of moving to AWS. So not only was our security stack, our full line of business applications, our databases, our full application stack and enterprise security solutions were migrated to AWS. So in the planning phases during our approach, we needed to configure and deploy CWP to protect on-premises and cloud workloads. And that's one of the nice solutions with CWP. It was able to give us that single pane of glass where our cloud ops team, our tech ops, our security team can go in and like monitor and control all our instances, either on-prem or in the cloud through one CWP console. Another requirement, just for background, we had to support all the environments that our requirement was for Amazon Linux, all the operating systems we currently leveraged on-prem and in AWS. So Red Hat, Windows, Amazon Linux was one of the requirements. And that's where CWP fit nicely. It supported all those natively, and as as Kevin mentioned, there are some things on the roadmap that we're looking at that would be able to do, like antivirus on the Linux host. That's something that we're very interested in, like continuing. But for our specific use case, we needed to continue with our real-time file integrity FIM monitoring, and that's where CWP fit nicely to give us that capability. Whether we're looking at like registry key files and OS files integrity monitoring that we're used to having on-prem, we needed that same capability in AWS. So we looked at a couple tools. We looked at what we currently had on-prem, and we looked at what CWP could provide, and we decided to do a proof of concept, POV, proof of value, to see what CWP could offer. It was very just some high-level observations and capabilities. It was very easy to set up a trial tenant with Symantec CWP, so we turned that on. We did a 30-day trial. We deployed some agents right out of the console. It was pretty seamless and easy to deploy the agents. It supported all our native OSs right out of the box, and we turned on what Patrick mentioned earlier. Is there's a way to do like a bridging, the bridge functionality between on-prem and AWS. When you turn that on, it links your on-premises data center host to your Amazon host. So we had visibility into all our workloads. That was very valuable to see from a compliance standpoint, which hosts needed to have the agents deployed and what policies needed to be in place. So out of the box, CWP provided basic OS level type policies and also file integrity monitoring policies. Those were set up and deployed to the agents, deployed to the hosts through the console very, very easily. And also, when you're looking at file integrity monitoring, there's also two modes that we looked at. The first mode was just testing the policies. So this was a way to see what triggers the policies would trigger on, what policies would be used. So it was very easy to go from test to actually production. It's just a flip of the switch in the console. So to us, that was very easy and valuable from going from test to production. It also has another capability that we're looking at. It doesn't only just monitor file integrity, but there's a way to actually block it and prevent. So that's something we're looking at for next steps, next phases, is not just monitor hosts for file integrity, but we're actually looking at turning on the prevention where it actually block some of those features Patrick discussed, is actually blocking or preventing like changes to environment or any type of threats that would possibly pose to the environment. So the results, we're pleased to say that we did ultimately decide on CWP to protect our workloads with the FIM capability. We're currently using that in production mode. It offered really no downtime. So if you're looking at evaluating CWP and looking at deploying it, it went from test to production really like seamlessly. There was no changing out policies. So the policies that we actually tested with actually migrated into the production environment. It improved, another impact, one of the major impacts, it improved monitoring and compliance efficiency and performance. There's automated rules and policies that CWP has out of the box. So as mentioned earlier, like it has a good visibility and visualization of our environment. So if a host popped up from DevOps or CloudOps team that was built and didn't have any policies applied to it, it would actually recommend to us, like the security operator or the security administrator, how to apply the policies. Is this a matter of turning it on and applying the policies? And those are all automated and recommended through the console. So that really improved our visibility and visualization of our entire AWS environment. Following along with kind of our architecture, one of the big requirements, because it wasn't a big, like a switch over from on-prem to AWS, we needed to operate in a hybrid environment. So we worked in conjunction with our cloud ops team. Cloud ops and our security team needed to be able to log into the CWP console and look up the hosts, see what was configured, do the visualization checks, and actually apply the policies. And we operated in this environment for more than 2 to 3 months because it's going to take a while to migrate all our data center into AWS. So we needed that hybrid approach, and that's really where CWP fit the bill for our requirements, is actually having the ability to protect and maintain that compliance readiness on-prem and also in AWS. So our cloud ops team and security team were able to monitor the migration to make sure we had no gaps in coverage or compliance reporting. So the hybrid approach was really what we needed, and that's where CWP really fit in nicely with the bridge functionality. We were able to protect our hosts and identify vulnerabilities that could potentially exploited our infrastructure through the threat and vulnerability intelligence that's offered through CWP, through the intelligence network. And out of the box, there's quite a bit of alert profiles are built into CWP. We've built a few custom FIM, file integrity monitoring policies. So it could alert not only in CWP console, but it has the alerting capability to alert to like an email or outside of CWP to give those cloud ops or security operations team those alerts that are coming in through the CWP agent. Just to reiterate too, like the agents, part of our requirements had to support Amazon Linux. That was one of the areas we were deployed in Amazon with Red Hat and Windows. It had to support all those environments, so that's where CWP gave us the capabilities we needed. Some of the summaries. I'm going to wrap up here. Finally, to finalize, we have time for Q&A after this, but really the proof of value results gave us the ability to maintain that security and compliance we needed to ensure what we had on-prem matched what we had in AWS. So CWP kind of bridged that gap where we needed that coverage. It was, like I said, very easy to install the agents. Initially, we did it just on a few test hosts, and then our cloud ops team was able to deploy the CWP agent through automation methods to deploy that to the workloads that we had in AWS. We had no loss of coverage as the result, so migrating from host to AWS maintained the right file integrity from on-prem to AWS, which is really what we needed. And really the built-in policies, I didn't need to develop any custom policies. I tweaked some of the policies, but really the ones that came out of the box were efficient to apply to the hosts. And some of those hosts that were built, kind of the net new hosts that were built from natively in AWS, if they didn't have the agent, the CWP visualization tool that was highlighted earlier from Patrick, would identify those hosts that didn't have any policies attached to it. So that's where I'd go in and apply the policies right through the console. It was very automated and easy to apply the policies. So what we're looking at for the future, just to wrap up, this was just the initial CWP overview and deployment. We're looking at extending that to other features. CWP offers, like Patrick mentioned, quite a few capabilities. One of them is the container protection for Docker. It's an area that we've starting to look into to provide Docker protection. It's an area that CWP has had, I believe, since June of this year, that capability to protect Docker containers. That's an area that we're going to leverage CWP for. And then, as I mentioned earlier, the FIM policies are great for detection, but we're going to turn those into more prevent mode to actually prevent potential compromise of a host or integrity of the environment for PCI readiness. And the antivirus on the Linux, that's an area that just was recently announced, or it could be very soon on the roadmap, where antivirus is built into the Linux agent to actually scan for viruses. And last but not least, I think Patrick mentioned this a little bit, towards the end of the year, there'll be support for micro-segmentation. That's an area we're going to look into and provide us the ability to protect and enforce control and compliance for the workloads up in AWS. So that concludes the customer case study for LifeLock, and I'm going to open it up for questions. Thank you very much.
Awesome. Thanks, Tom. Hey, everyone, it's Pat McDowell again. If everyone has any questions, feel free to post them on the right-hand side. You should see a little tab for questions. Type right in there, and we'll try to answer as many as possible. And once again, if we don't get your question, we'll follow up after.
And I see we've got quite a few in, and so there was a couple here in the time we've got to, like to jump on. So there are questions around the agent and installing it and the anti-malware, as you just heard Tom go back on their interest. So in the August timeframe, we took the SEP engines, the Symantec endpoint protection, which provide anti-malware protection, including the new machine learning, and have integrated them in with our single Linux agent, single console. And today there is on-demand scanned, API-based, as well as then scheduled scan. Come the beginning of next year, it'll have the real time, and we're really focused on, as you do that, when you need that on that workload, is the ability to minimize the impact on the server. We've worked with our engine teams to reduce the footprint, as well as divide the protection such that I can have a lighter weight. I'm focused on protecting the limited number of attacks on Linux to ensure I am not seeing rootkits or worms or any of the ones that are on Linux. There's a handful of them. And then the other need of, I know I am accepting inbound files and I'm not writing to S3, I'm writing to local block storage. So that ability to, on that block storage, do the fullest Windows scan to ensure that my data center is not being used as a place for malware to reside. You'll also see, just as we've done on Linux, that Windows blade come in to where the Windows will have single agent, single management of anti-malware around the same time frame. And some of the others were about, so the offloading of the anti-malware, the vast majority of these apps are writing to S3. And so what we see in this world, especially our customers with cloud native, usually the extremely lightweight, lock from the start policies, which Tom was just talking about, to enforce and monitor the controls. And then I am watching the anti-malware by sitting on S3 and ensuring that the malware is not getting written or processed by any of my data center. And the other thing I want to leave you with is with CWP, it is available within the Amazon Marketplace. You can go out and try risk-free. So you have the ability to do a 90-day, 20,000 hours to go out and use the solution, look at it in your environment, and we're here to help you. If you've got any questions, and a note on that is you'll see if you look in the help system, we even provide an out-of-the-box CloudFormation template that lets you spin up a test environment, including a number of workloads in an application that allows you to attack that demo environment with some basic web attacks as well as Dirty Cow, and we'll continue to add to that on things that we can safely place up there. We're still trying to find a way to neuter pet yet to where we can give that to you to play with. So we go out and see and test CWP before you begin looking at it within your environment.
Great, thanks. So we got Kevin, I'm seeing a couple questions here. Can you talk a bit about operating system support as well as maybe some other platforms you might support outside AWS? Okay.
Sure. So as you probably saw on my slide, we have extremely broad platform support. And one of our keys to it is even when that platform goes end of life, like Windows 2003, Windows NT, Red Hat 4, we still provide support for that so that customers who need to do patch mitigation and have services they need to run. So we run the full gamut across the Linux, Windows, as well as even getting into the IBM platforms not only AIX, but some of their mainframe platforms we've got support for. So very broad support. And then in the newer, right, we have the Docker as well as the Pivotal Cloud Foundry support within there, and is besides supporting Amazon Cloud, there are other public clouds we'd be happy to talk to you about, because our goal there is to ensure that we can protect your workload wherever it resides.
Great. Thanks so much, Kevin. Hey, everyone, we're about out of time for questions, so if we didn't get your question, we'll follow up directly. Just want to thank you for attending, and thanks for Tom and Kevin for joining me on this webinar today. I hope everyone found it very educational.